This is going to be a talk about Exposed, a Kotlin database access library that was built in 2013 by JetBrains employees for internal use. In 2016, the library became publicly available as a team project under the JetBrains open source group. And while it rose in popularity, for the majority of its existence, it was primarily maintained through the efforts of a single employee in their free time. Fast forward to 2 years ago, the team that I'm a part of was established to work full-time on maintaining and improving the library. And then 1 year ago, we attended KotlinConf to give the first official status update on the project, both as a way of showing our commitment to Exposed being a part of Kotlin on the server side, but also to very much just say, hey, there is now a team 100% behind Exposed. Our core team is small, comparatively, but we are supported by other teams and by colleagues who use and contribute to Exposed in their free time and in their not-so-free time. And that level of support internally and also externally from the community has led us through 25 releases since the team first came together 2 years ago, and it's all been leading us towards this point. This special point that sits between a 0 and a 1, our first stable release, and honestly, a milestone moment for the team and for the project. Thank you. So I'm here today to cover 4 things: what the team's been up to since the last update, a look into how to use Exposed, but primarily highlighting the feature changes over the last 2 years, to underline it with why the stable release is a turning point for the library, and to wrap it up, where Exposed is headed post 1.0. So let's start with the major developments in the last year. Documentation has been a constant pain point with Exposed in many user feedback, and one of the first ways to address that was to remove the official GitHub wiki and replace it with an official Exposed documentation site. The team has been working steadily towards improving the overall meaningfulness of the documentation site by fleshing out, reorganizing, and restructuring a lot of the missing pieces. We've also accumulated all the sample projects into a single location. We've also added a Getting Started tutorial to give you a walkthrough guide from setup to running a sample application. And new and old samples can be found together in a single place, some new like our migration samples, some old like how to set up our Spring Boot starter with Exposed. And all of our API documents are now located in one location on one site. Exposed is also accessible directly from the JetBrains landing page under the Developer Tools dropdown in the Languages and Frameworks group, which leads directly to the new Exposed website, an all-in-one place for all of our documentation, our code base, and all of our support channels. But the primary major feature that we've been working on over the last year has been an entire refactoring of our code base to take the existing support for JDBC drivers and make them compatible with reactive drivers. R2DBC support was one of the oldest open issues faced by the team, with some variation of lack of asynchronous support always being a constant point in user feedback. The team has heard, and now R2DBC support is available and open to try in our beta release. So if R2DBC is something that you've been waiting for, please consider giving our beta release a try. Implementing the R2DBC feature came with its own unique set of challenges. It was a very large task to prepare for and encompass in its entirety. A huge, significant chunk of the code base was heavily reliant and tightly coupled on concepts that were not compatible with R2DBC integration, leading ultimately to a large refactoring, extracting, and redesigning of many of our original core classes. But what you probably want to hear is, what does this mean for you? So I'm going to do a very basic this versus that so you know what to expect with R2DBC. First things first, database driver support. These are the databases that are currently supported by Exposed. For R2DBC, we support any that have a native driver implementation. So everything except SQLite. Now that you have a database, how do you connect to it? We call database connect to create an instance of a class that represents the underlying database being used. We provide a URL connection string and any global level configuration parameters that should be applied to every connection in the future when it's requested. With R2DBC, it's the same concept, except we're calling connect on an R2DBC database, providing a similar configuration parameters and connection string. And much in the same way that JDBC has overloads, whether you want to provide a data source or a function to get a connection instance directly, R2DBC also has overloads, whether it's a mining URL, a pooling URL, or whether you want to do programmatic connection factor discovery directly. And now that you have a means of getting a connection, you want to perform a unit of work, you want to open a transaction. With JDBC, we call transaction. To get a JDBC transaction instance, we provide our database, we provide transaction level configuration parameters, and in our transaction lambda, we can perform any database operations that we want. The R2DBC variant is similar. It is currently called suspend transaction. It takes an R2DBC database instance, the same similar configuration parameters, some specific coroutine ones, and it inside the R2DBC transaction, we can perform the same database operations. Now, what do these operations look like? The majority of SQL commands in Expose are available as table extension functions, like the insert and update here, or they're available as methods from the schema utils object. Schema utils just being an object that holds multiple methods for creating, altering, and dropping database objects. And while the underlying statement class has been significantly redesigned to be separated into statements versus executables, the API itself has not changed for R2DBC except that they now suspend. What about fetching results? The main way to instantiate a query class in Expose is to call select all on a table. And once you have a query instance, you can continue to chain methods that represent SQL clauses like where and order by. And with R2DBC, that does not change. Because you can continue to chain as many methods as you want on a query instance, and it will not actually be sent to the database until the first terminal operator attempts to iterate over the results. And that's where the difference between JDBC and R2DBC starts, which is why any terminal query methods like count and method and empty with R2DBC would now suspend. Because ultimately, if you were to, for example, call toList on a JDBC query, it would trigger sending the query to the database. The results will be returned and processed as a result row, the result row just being a class that represents a single record from a result, because the JDBC query implements an iterable, so we can use any method from the iterable interface on that query. Whereas with R2DBC, if we were to call toList, the same thing would happen. It would be sent to the database. We would get a list of result row. But the R2DBC query implements a flow. So now what you're getting is a flow of results that you can consume. And those are just the basic 5-point differences between R2DBC and JDBC. A more in-depth guide is going to be dropping imminently while we process the first round of feedback that we got from our release last week. So please consider giving R2DBC a try. Please consider that if you do, drop any feedback on the UTrack issue, whether it's about naming or design or any issues that you found. So while R2DBC was the major release for 1.0, there's been a significant number of improvements added to the libraries in the last 2 years. So let's look at some use cases. This is UTrack. It's a project management tool built by JetBrains, and it's the inspiration for this year's demo. It's also a project issue tracker, uses the same module, but I really legitimately wanted to call it BooTrack. So instead of tracking regular issues, it tracks paranormal events. It uses Exposed, it uses Postgres, it's got 2 backends, one for JDBC, one for R2DBC. It uses KTOR both on the server and on the client, and it's built with Compose Multiplatforms for desktop. I should note that any links that I've made, including the link for this repo and the link for all the exposed documentation and sites, will be placed at the end of the slides for reference. So it should be noted that this demo was built to showcase the highlight feature changes in the last 2 years for exposed. So it was built to show what exposed can do and not so much what maybe exposed should do. So please keep in mind, if you're checking out the repo later, that any design choices in the demo may not be the simplest or the most efficient from a purely database design point of view. Just a disclaimer. So we're going to start at the place where it always starts, mapping our data models. This is the simplest model in our demo. It's a projects table. Every issue has a projects. This is an exposed table class. It is the core class for building schema in exposed. And if it seems, for those who are used to exposed, that I'm starting really basic, I'm starting here on purpose to ramp up somewhere, I promise. So just bear with me. The table class comes with methods to register columns, like an integer column to store our ID value. It comes with specific table properties like a primary key. And columns themselves have methods that allow you to define their settings. For example, defining that our column is going to auto-increment on the database side. We can register as many columns as we want, like a column to store strings, and another one that has a check constraint and a unique constraint. And this type of construct is so common, having an ID with a primary key, that we can actually avoid and skip these 2 steps and extend a subclass that's typed the integer ID table directly to do those steps for us. But what if we wanted something custom with our ID column? What if we wanted to either not have it auto-increment, or we wanted it to auto-increment, but with a specific sequence in mind? If we attempted to do this with that integer ID table, it would not work. Instead, we would need to extend the base ID table directly past the type that we want, take the custom column that we're interested in and use it as the override for the ID property, and then tag that column as the entity ID column and give it the right type with entity ID. But here's the thing, if we're able to take this ID table, pass it any type and any column, then feasibly we should be able to do that with any type and any column. But in the past, this was not possible. We were restricted to only comparable types. That restriction has since been lifted, which means that technically now, if you want an ID table, you can technically pass any type that you want, even if you want a data class. And if you choose to use a data class as an ID or a key, you don't have to worry about what type of column you're going to store it in. You can use an existing column type, and you can now call transform on your column to define the way to take a client-side value and send it back and forth from the database in a way that makes sense. By defining conversion functions, one to take your data class and store it in a way that the database understands, and vice versa, a conversion function to take the stored value and convert it back into a data class. Making things like insert as simple as inserting an instance of your data class to the column in your statement, and selecting it is as simple as reading the result stored in the column in the result row. Now, these insert and select all read and write operations are part of the domain-specific language approach offered by Exposed, which is meant to offer type safety, but in a way that feels and reads like standard SQL. And even though the ID table that we've seen is very commonly associated with the data access object approach, which still offers type safety, but is less verbose and abstracts away even more the underlying implementation of how data is being accessed. With the DAO approach, each record in the table would be associated with an entity class instance like project entity, and methods like insert and select would be replaced with new and all, and we would be using the fields to set and get values directly instead of any association to table columns. So if the DAO approach is something you're familiar with, if it's your preferred flavor, please consider checking out the demo. because it shows how to really well leverage your entity class to accomplish everything that we're about to see with DSL. So if we look now at the issues table, which is the main table in our demo, we can see that it has two key component columns. And one of them is part of a many-to-one relationship with the projects table. If we wanted to do this with DSL, it would be really simple. We would just have a column to store the first component, and we would have a column to store the second component. And because the second component is storing the ID value from the project parent project table, we call references, which just tells Exposed to also additionally create a foreign key constraint between these two tables. And then we would just pass that to the primary key as the two key component values. But what if we wanted to make this compatible with DAO? We could attempt to do something we saw in the past. We could take the ID table and pass two different types. Or we could now use the composite ID table directly, which does that for us. So what do we do to set it up? We just create the same column that we were interested in, but we tag it as entity ID to make sure that we know that it is the ID column. And we do the exact same thing with the other column. We just have to be a little bit wary of where we're placing that modifier, just so that the references foreign key constraint created afterwards doesn't complain that the type match between the parent and the child is wrong. Because we can continue to add as many columns that have foreign key constraints by using reference, which does those two things for us. It registers a column and it creates a foreign key constraint, and in the event the foreign key constraint can be nullable, we can use optional reference. Because ultimately, Expose attempts to always give options when it comes to how you define your data and how you define your schema. You can use convenience functions like this to make your life a little bit easier and replace all the standard SQL that you're used to. Also handle any database differences in case you're using the same objects across multiple databases. Or on a lower level, you can take the full control and you can actually register the columns yourself and create the foreign keys yourself. So a lot of the types that we've seen so far have been very kind of standard. Let's say, for example, that in our demo, there's a bunch of settings that the users can play with. They can turn them on and off, and we don't want to think about what these settings and how we're storing them and whether they're changing over time. So let's just say we want to store all these settings together as a JSON, which we can now because JSON and JSONB is immediately accessible from Expose. If we have, for example, a data class to store our settings, and that data class is serializable, we can pass it as a type to our JSON column, and we can use a shorthand format to store JSON values. If we were using a different serializer, we can use the long form of JSON and provide serialized and deserialized functions to map how we're going to parse our JSON. And that way, inserting is as simple as passing a data class instance. And if we were to read the value, it would be as simple as getting the entire value back. But in the event we want to deal with specific key value pairs, we can actually use some built-in JSON functions and operators that are immediately accessible out of the box. Now, what if, when the user is looking through the issue summary list, they can toggle two properties. They can toggle a star to track or untrack, and they can toggle a votes to upvote or unvote. There's a lot of ways we could accomplish storing this. We could have additional tables with additional joins. But let's just say that we want to put it all in the same issues table, and we want to store the array of user IDs as an array. It's now possible to store arrays in single dimension and multiple dimensions with Exposed. We just simply call array with the type, whether it's single or multi. For us, we're just wanting to store a single dimension, so we provide a list of integers, and we would get back a list of integers. And now if we actually want to accomplish our task, we would need to actually have custom functions. I won't go into the detail of how to create a function or an expression with Expose. That has not changed in the last 2 years. It's all in the demo if you're interested. But we have a function to add. We have a function to remove. We provide it to our custom switch block to essentially say if you see an element that matches this stored in the array column, remove it, and if you don't, add it. And then what we would like to do is we would like our issue to be updated, but if the issue did not already exist, we want it to be inserted, and it is now possible to do upserts with expose. So we can call upsert on our table, we can provide a where clause to make sure our issue keys match, we provide a standard insert statement, which is setting values to our columns in the insert statement block. And in the event we're performing an update, we can provide our special array function to make sure that's updated. And because additionally, when it's updated, we want the timestamp of the issue to be modified, we can tell expose to set up the syntax of the statement to use what would have been inserted by calling that column with insert value. Now, the only one other thing that has changed is that we can take existing column types and we can actually append onto the SQL that will be generated when we create the table. So if we have an existing column type and we want to do something, for example, to make sure that it is always generated as the result of a string concatenation between two other columns, we can now define that ourselves by using with definition. With definition can be used for anything, whether it's a hard-coded string or multiple functions or expressions. And in this event, we would also just need to add an extra flag to say that this column is database generated to make sure that expose doesn't attempt to fail early when it realizes that you're not inserting into this column. Now, what if you wanted to use a completely different data type that wasn't at all supported? What if we have a column that shows issues based on location? So issues that are within a certain radius of a location defined by the user as their maximum travel distance. Spatial data types are not currently supported by Exposed, but that's not going to stop us because Exposed gives us the means to create these data types ourselves. So we can do so by extending column type. We have our own special data class to store our location. We create a column type that will accept that data class, and the only two methods that are absolutely necessary for defining our column type is to say what does that type map to in the database, for us is geography, and how to parse the value that's returned by the database from that column type. We can add a couple extra just for peace of mind, for example, when we're logging strings to make it easier to read. And then we create an extension function on our table class to allow us to register a column of our new custom type. And then we're able to use that type in our table to have a nullable geography column, and inserting into our table is now as easy as just inserting a data class instance. So we've looked at some types, we've looked at upserts. What about other changes in statements? When we insert a new record, we want a new page to load that shows all the details that we've inserted, but we also want to show two new values, the value of the timestamp when we inserted the record, and a special unique code for that issue. We could handle all that logic on the app side if we wanted to, but let's make the database generate all those values. Because now, if your database supports it, it is possible to use returning clauses on all database operations, whether it's insert, update, or delete, or even upsert. So we call insert returning on our table. In the Lambda block, we pass the standard insert column setter value mappers. And then we provide an optional argument to say exactly which columns we want to be returned, because if we don't, by default, it will return all columns. And we're able to get the database generated values we want. But because this statement expects a result to be returned, it's going to act like a query, not like a standard insert, and it will not be sent to the database until we perform some terminal operation that attempts to iterate over the results. And in our case, that's just a matter of getting the single result, passing it to our converter function, and handling it if we don't get a result back. Now, when we're inserting, one of the things that we may want to ensure is data consistency across tables. Let's say, for example, every time we insert a new comment into our issue, we want that parent issue to be updated with a timestamp that matches the timestamp of the newly created column, a newly created comment. The comments table is itself a composite key, and it has a foreign key on the issues table. So what we need to do is create a join between the two of them. Expose allows you to both create implicit and manual joins. We're going to do a manual join here because we want to give all the details. So we call join in our table, we provide the actual type, and then we have to specify the actual columns involved in the on condition based on our foreign key constraint. And now, using that join, we can treat it like a regular table, and we can call standard updates or even deletes if we wanted. We can call updates on our joins to ensure that only the parent issue that matches and is referenced by the child comment is the one that actually is updated with the modified timestamp. Now, what if we wanted to synchronize data across entire tables? What if we had, for example, a notification system, and we're relying on a primary permanent table, but we have an active user session table, and whenever that active user session is shut down, we want to make sure that any changes in that table are reflected in the permanent table. To do all this in a single statement, what ideally would be nice would be to use a conditional merge. And it is now possible to use merge statements directly from exposed. So we can call merge from on our destination table. We provided our source table, and we can start building any number of conditional branches to fit our needs. We can add an insert branch in the event that a match was not found. We can add a branch that does nothing in the event we found a match, but the notification was not read during the session. And then we can add a branch that deletes the record in the permanent table if we found a match and the notification was read. Now, what about querying data? Let's assume that in every time we've seen an issue summary list, we've been using a base table data. We're not going to go into the specifics of what double join query is. From the name, you can probably guess that it's a join between two tables and a query. And this is a standard base query that we're always using to get back every issue summary list. But now the user has a saved search. So they're not just getting back an issue list, they're getting an issue list that's grouped by the issue priority level, and then within each group, each issue is ranked by either something of their choice, how long it's been open, how many stars it has, how many upvotes it has. One of the first ways to do this, let's say we're going with the number of upvotes, we're going to decide how to define that. We have a custom function for the array length that says how many elements are in an array, and then we're just going to use a built-in coalesce to make sure that we always have a non-null value returned to us. And now it's possible to actually use window functions directly. So what we want is a dense rank. We want to make sure that we're partitioning by the priority level of the issue. We're ordering by the function that we just created, and we're aliasing it. And we want to get this dense rank, this window function back, but we also want to filter by this window function. So ideally, we'd like to simplify our lives by simplifying the query. And one of the go-to ways to do that is to use a common table expression. And if you're familiar with Expose, you would know that that is not supported. But once again, what we should be getting is that Expose gives us the tools to do this ourselves. So it is possible to use CTEs ourselves by extending on the table class. I haven't put any of the specifics of how that's done. It's all in the demo if you're interested in taking a look. But we basically create our own with class that extends table, takes a name, and it takes the query that we're interested in. And what query we're going to use? We're going to use the base query that we've been using all along, because the power of queries is that every time you need one, you don't necessarily need to build it from scratch. If you have an existing base query, you copy it, you can adjust it to fit your needs. So we're going to say, take the original query, take everything that you were selecting, all columns, all aliases, add the window function, and then we're also going to adjust the where clause. We're going to say normally the adjust where is to completely 100% override the where, but we can also use it to just tack on an additional condition. But in the event that we want to just add an addition, like ours, where we want to say, in addition, also filter all issues that have been completed, we just have to handle the event that there was no where clause in the original query. So just we need to handle that null event ourselves. And then we can take our custom CTE and we can treat it like a regular table, select all, calling where, using our window function, and expose gives you different options when you have alias expressions. So you can use the alias directly, you can use the delegate, or in our case, we're just using the alias string. And that's just the highlight of some of the major features that have gone into the library in the last 2 years. There's a lot of other things that are possible using Exposed. So please check out the demo if you're interested in the extra stuff. And especially if you're interested in DAO, do consider checking out the demo. So with everything that we've seen with Exposed, why is a stable release different for the library? It's been a bit of the wild, wild west these last 2 years, to be honest, getting exposed to a robust state. And part of the 1.0 milestone means making a commitment to a release process and a version of Exposed that gives you more confidence to use it. So what that means is, moving forward, we're going to be adhering to a stricter release policy where you can rest assured that all the public binary API contracts that I mentioned before will actually be respected. There will actually be no breaking changes until the next major version, and any new features implemented will actually retain the expected backwards compatibility. We're also committing to more clear communication on what exactly it is the team's been working on with official roadmaps, so that all of our goals, our initiatives, our plannings will actually be publicly available in the event that you choose to be involved with them. And stability also brings exciting opportunity for more ongoing improvements at different levels of the code base. So let's take a look at what some of those improvements are going to look like. So what's next for Exposed? As part of our initiative towards refinement, we're going to be focusing on performance as a whole. We're going to be actually taking the time to test for points of improvement. We're going to be checking for potential overhead from places, particularly opening transactions, getting connections. And we're going to be assessing whether there's any room for improvement, any room for optimization under the hood at certain points, like when we do metadata query fetching and DAO eager loading, in the event that there's any potential performance boosts that could be translated directly to the users. We are also considering revisiting and redesigning certain aspects of the DAO design. If you consider DSL to be the core of Exposed, and then you take DAO to be built on top of it, doing its own thing, one of the great things about Exposed is that it doesn't necessarily lock you in to one or the other. You can have as much or as little of either approach as you would like, the DIY way. But we acknowledge that this way can occasionally be confusing, primarily because the inner workings of DAO are not necessarily as what you see is what you get as it is with DSL. So we're actually going to be taking the time to work on some of the layers of DAO, like the cache, to actually increase the awareness of the underlying mechanics. So for example, how and when we load and send changes to cached entities to the database is going to be more readily documented to reduce the likelihood of unexpected surprises when using DAO, especially when using DAO with DSL. We're also going to offer an option for more user-defined control of the actual entity management state and cache by offering the option for second-level caches and cache providers. Also, we're going to be moving forward with a plugin that addresses an issue that is has been left out of Exposed for quite a while, migration assistance. It is currently possible to use migration utils from the Exposed migration dependency. It has significant improvements over the original schema utils, especially where it concerns generating migration scripts and better database schema validation methods. This has been available for a little while. There's also more documentation about migration, but there is currently a plugin, a Gradle plugin that is under development to simplify the overall process for this. And in moments like this, we're trying to encourage more engagement. So if migration is something that you've been waiting for or something that you're excited for, please consider upvoting these issues on UTrack. Please consider going in and actually checking out the current design of the plugin and being part of the decision-making process if that's something that you're interested in. I started this talk by saying how much the community support has led to where Exposed is today. And I'd like to finish it by emphasizing how integral all of you are to where it could be tomorrow. The last time Exposed hosted an official survey was last year, spring around this time, 2024. The plan is to publish another one in the upcoming weeks. And so please take a look out for that on both the Exposed and the Kotlin social media platforms. The hope is that many of you will participate. You'll let us know how you feel about Exposed and what you think it could look like in the future. So thank you for sticking around with me. I know that we're very close to lunchtime, so I understand that everybody's probably eager to get up and go. Please consider checking out the demo. Please consider dropping by the demo booth where I'll be for the rest of the day if you have any extra questions, although we do have some time for questions now. And I hope you all enjoy the rest of the conference.